Welcome back to another video in which we will solve O-Level Mathematics Paper 2 Variant 2 for October-November 2018. So question number 1 is Kamal earned a total of $32,500 in 2017. He paid 9% of this amount into his pension. He paid 22% tax on the remainder of his earnings. Calculate the amount left after paying his pension and his tax. So let's first calculate how much pension he paid. So pension is 9% of this total income. So this is 9 over 100 into 32,500. So 0.09 into 32,500. So this is 2925. And then the remaining amount after pension is 32,500 minus 2,925. So 32,500 minus answer. So this is 29,575. Now he paid 22% tax on this remaining amount. So let's calculate the tax, which is 22 over 100 into 29,575. So this will be 0.22 into 29,575. So this is 6506.5. 6506.50. And then you have to calculate the amount left after paying his pension and his tax. So final amount left will be this one, 29,575, which was left after pension minus the tax, 6,506.50. So this will be 29,575 minus 6,506.50. So this is $23,068.50. So 23,068.50. Part B is Kamal invested $1,200 in a savings account paying 1.8% per year compound interest. He left the money in the account for 5 years. Calculate the amount of money in the account at the end of 5 years. So, you know, the formula for the compound interest is the principal multiplied by 1 plus the rate over 100 to the power n, where n is the number of years. This is n. So the principal investment is 1200, and then 1 plus the rate is 1.8%. So this is 1.8 over 100, and the time is 5 years. So n is 5. So this will be 1.8 divided by 100 plus 1, and this power will be 5, and then multiplied by 1200. So this is 1,311.96. So $1,311.96 will be the amount in this saving account after 5 years. Part C is Kamal also invested some money in a different saving account for 5 years. This account paid 2.1% per year simple interest. At the end of 5 years, there was $828.75 in the account. Calculate the amount of money he invested in this account. So we know that at the end of 5 years, the account balance was $828.75. So that means the principal amount that was invested initially plus interest that was earned in 5 years. If you add them together, that is the balance of the account, balance of account after 5 years. So this is the amount of money that will be in the account after 5 years, which is the initial investment, which is the principal, plus the interest earned in 5 years on that principal amount. So we have to calculate the amount of money he invested in this account, which is the principal amount. So let's call that P, plus interest earned in 5 years will be PRT over 100. This is the formula for simple interest. And then balance after 5 years is given as 828.75. Now we can substitute the values. P is unknown, so this will be P plus P into rate is 2.1%, and the time is 5 years over 100 equals to 828.75. So let me continue here. So if I take the LCM, I will get 100P plus 5 into 2.1 is 10.5P plus 10.5P over 100 equals to 828.75. So this will be 110.5P will equal 828.75 multiplied by 100. So this will be 828.75 if I take this 100 to the other side, and then P will be this divided by 110.5. So 828.75 divided by 110.5. So this is 750. So the initial principal investment that Kamal made in this savings account was $750. Part D is the exchange rate between dollars and pounds is $1 is 0.72 pounds, and the exchange rate between dollars and euros is $1 is 1.1 euro. Kamal has $275. He changes part of 275 into pounds and receives 79.20 pounds. He changes the remaining dollars into euros. Calculate the amount of money he receives in euros. So first we need to find the remaining dollars. So he converts part of $275 into pounds and receives 79.20 pounds. So if I have dollar ratio pound, so I have $1 is 0.72 pounds here. So let me put a ratio sign here. And then you have to calculate the dollars, let's call them X, for 79.20 pounds. So if I cross multiply and form the equations, I will get 0.72x, 0.72x equals to 79.20. So x will be 79.20 divided by 0.72. So this is $110. So out of the 275, he used $110 to get 79.20 pounds. So remaining dollars equals to 275 minus 110. So 275 minus 110. So this is $165, which he then converts into euros. So what is the ratio here? So $1 is one. So let me actually write it above here. So dollar ratio euro. So $1 is 1.10 euro. And then Kamal converted $165 into, let's call them Y euros. So Y here will be simply 165. So I cross multiply again like this. 165 into 1.10. So 165 multiplied by 1.10 is 181.5 euros. So this will be 181.50. 181.50. So this is the amount of euros he receives. Question 2 is Lim grows tomatoes. The masses m grams of 200 of our tomatoes are recorded. The cumulative frequency table shows the results. So there were 0 tomatoes that were less than equal to 80 grams in mass. There were 20 that were less than equal to 100 grams, and so on. On the grid, draw the cumulative frequency diagram to represent these results. So on x-axis you have mass, and y-axis you have cumulative frequency. So first value is 80 and 0. So this will be your first point. The next value is 120. 120 will be this value. 110 and 48. So 110, 40, 45. Let's see if there are 5 blocks and the value changes by 20. So 20 divided by 5 equals to 4. So each small block here represents a value change of 4. So 48 will be, this is 40, this will be 44, this will be 48. 2 blocks above 40. Then 120 and 112. 120, 100, 104, 108, 112. 130 and 158. 130, 140, 144, 148, 152, 156, and then 158 will be here in the middle. 140 and 184. 140 and 184 will be this. And then 160 and 200 will be this value. So now let's try to draw a smooth curve for these points. So this will be your cumulative frequency curve. Part B is use your diagram to estimate the median. So median will be 50% of the frequency, total frequency. So 50% of 200 is 50 over 100 into 200, which is 100. So you have to find the mass when cumulative frequency is 100. So which will be this line here. This is the 100 line and it intersects the graph. So it's in the middle of this block. So if I go down in the middle of this block, I will end up here. So this is 110, 112, 114, 116, 118. So this is between 118 and 120. So I can write 119 grams. So the interquartile range. So first you will find 25% of 200 will be 25 over 100 into 200. So 0.25 into 200 will be 50. So this will be your value at 50 will be your lower quartile, and then you also need 75% of the frequency. So 0.75 into 200 will give you 150. So let's look at these values. So 50 is this line here, 40, 44, 48, and then 52. So 50 is in the middle here. So let's see what is the value at 50. So it's in the block, in the middle of this block here. So interquartile range will be upper quartile minus lower quartile. So lower quartile is 110, 112, 111. So minus 111, and the upper quartile value will be at 150. So 140, 144, 148, 152. So 150 will be in the middle of this small block. So I'll see where this line intersects the graph. So it's this point here. So this value is 120, 122, 124, 126, 128. So this was 111, this was 128. So 128 minus 111, 128 minus 111 is 17. So your interquartile range is 17 gram. Part C is Ravi also grows tomatoes. The masses of 200 of his tomatoes are also recorded. For Ravi's tomatoes, the median mass was 124 gram and the interquartile range of the masses was 12 gram. Make two comments comparing the masses of tomatoes grown by Lim with those grown by Ravi. So the median here for Ravi is 124. For Lin, the median was 119. So that means average mass of Ravi's tomatoes is higher than Lim's tomatoes. So we can say average mass. So median is also kind of an average. I know that usually we call mean the average value, but median is the middle value, so it kind of relates to the average mass as well. So average mass of uh, Ravi's tomatoes is higher than Lim's tomatoes. And the second value we are given is the interquartile range. So Ravi's tomatoes have an interquartile range of 12 gram, whereas Lim's tomatoes have an interquartile range of 17 gram. So this interquartile range is higher. So that means the masses of Ravi's tomatoes are more consistent because the masses are not much more like are less spread out compared to Lim's tomatoes because the interquartile range is smaller. That means the values of masses are closer to each other compared to the mass values of Lim's tomatoes, because here the interquartile range is bigger. That means the distribution is bigger. There is a like wider variety of ranges of masses compared to a smaller interquartile range. So we can say that masses of Ravi's tomatoes are more consistent, are more consistent compared to masses of Lim's tomatoes. So these are the two statements that you can make, one regarding the median, the other regarding the interquartile range. Part D is complete the frequency table of tomatoes grown by Lim. So you're given the class values here and then the frequency values. So the first value that we have to write is for the class, that is from 120 till 130. So if you look at the cumulative frequency table, so to find the masses between 120 and 130, so 120 and 130, we will subtract 112 from 158. So 112 tomatoes have mass less than 120, less than or equal to 120. And 130 oh sorry, 158 tomatoes have masses that are less than equal to 130. So how many are in between 158 minus 112? So 158 minus 112. So 46 tomatoes have masses in the range of 120 to 130. So this will be 46. And then the next is 130 to 140. So 130 to 140 are these two values. So this will be 184 minus 158. This is 26. Write down the model class. So the model class will be the one which has the highest frequency. So here 64 is the highest frequency, which is this class. 110, m is greater than 110 but less than equal to 120. Part 3 is calculate an estimate for the mean mass of these tomatoes. So since we are given class values here, we will use the mid values. So let me draw another column here. Let's call this mid value X. So what is the mid value for 80 and 100, which is 90. Mid value here will be 105, 115, 125, 135, and then 150. So these are the mid values for these classes. So let me extend these lines here. And then you multiply frequency into mid value. So 20 times 90 is 1800. 28 times 105 will be 2940. 115 times 64 will be 7360. 125 times 46 will be 5750. And then this will be 3510. And this will be 2400. So now your mean here will be sigma fx. So sum of all these products, the multiplication that you did divided by sum of all these frequencies. So we already know that sum of all these frequencies is 200 because the final value of the cumulative frequency is 200. We are given that the masses were for 200 tomatoes. So this will be 200. And then if you add all of these together, 1800 plus 2940, 7360, 5750, 3510, and 2400. So this is 23,760. And then this divided by 200 will give you the mean. So this is 118.8. So this will be your estimate for the mean mass of these tomatoes. Question 3 is expressed as a single fraction in its simplest form. So we will take the LCM here. So LCM will be y minus 1 times y plus 6. So this y minus 1 was multiplied by y plus 6. So the numerator will be multiplied by y plus 6 as well, minus 5. So this y plus 6 was multiplied by y minus 1. So this will be multiplied by y minus 1 as well. So let's open these brackets. I will get 3y plus 18 minus 5y plus 5 over. I'll leave them as it is because you only have to express as a single fraction. So you don't need to open the brackets in the denominator. If you want, you can do that as well. So this will be 18 plus 5 will be 23 minus 5y plus 3y will be minus 2y over y minus 1 into y plus 6. So this will be 23 minus 2y over y minus 1 into y plus 6. Part B is simplify this expression. So in the numerator, I can factorize this quadratic equation. So I have this number is minus 12, which has no variable, and the variable with power 2 is v square, so its coefficient is 2. So if I multiply the 2, I will get minus 24. So now since this is minus, I have to find two factors of 24 which should subtract and give me minus 5 as a result of their subtraction. So I can take my 8 and 3 are the two factors. If I multiply them together, I get 24, and minus 8 plus 3, I'm subtracting the 2 and I get minus 5. So let's do that. 2v square minus 8v plus 3v. So minus 8v plus 3v will give me minus 5v. And then minus 12. And then v square minus 16 can be written as v square minus 4 square. 16 is 4 square. And then in the numerator, I can take 2v common. This will give me v minus 4 and plus 3 common. This will give me v minus 4 as well. And I can use the formula a square minus b square equals to a plus b into a minus b in the numerator. So this will give me v plus 4 into v minus 4. And then v minus 4 I can take common. So 2v plus 3 times v minus 4, and then divide by v plus 4 into v minus 4. So v minus 4 and v minus 4 can cancel out, and I get 2v plus 3 over v plus 4. Part C is solve this equation, show your working, and give your answers to correct to three significant figures. So let's open this bracket. So I'll get 3x squared plus 9 equals to 11x. And I can bring this 11x to this side to 3x squared minus 11x plus 9 equals to 0. So now I can use the quadratic formula to find the value of x. So x is equals to minus 11 plus square root of b square. So this will be minus 11 square minus 4 into AC 3 times 9, and then divide by 2a 2 times 3, and or x can be equal to again minus 11 and then minus square root this time 11 square minus 4 into 3 into 9 over 2 times 3. So this will be 11 plus square root of let's see, 11 square minus 4 into 3 into 9. So I didn't use minus 11 square because minus square will become positive anyways. So 11 square or minus 11 square, you'll get the same value. So this will be square root of 13 over 6, or x is 11 minus square root of 13 divided by 6. So this will be, let's see, 11 plus square root of 13 and then divided by 6. So up till three significant figures, this will be 2.43. And the other value is 11 minus square root of 13 and then divide by 6. So this will be 1.23. So this value here will be 1.23. So 2.43 or x equals to 1.23. Question number 4 is Anna drives 45 kilometers to work each day. One day she drives the first 25 kilometers at an average speed of 82 kilometers per hour. She takes 36 minutes to drive the remaining distance. Calculate her average speed in kilometers per hour for the whole journey. So average speed is total distance divided by total time taken for the journey. So we know that total distance is 45 kilometers. And then total time is what we have to calculate first. So total time for the second half is given is 36 minutes. So time will be equal to, so let's calculate for the first half. So the first half, she drives the first 25 kilometers at 82 kilometers per hour. So this will be distance 25 divided by speed 82. This is for the first half of the journey. And for the second half, since this is in hours, because we are dividing kilometers by kilometer per hour, so we will get this time, which is for the first half of the journey, in hours. And then she takes 36 minutes to drive the remaining distance. So total time is this plus 36 minutes, but I have to convert 36 into hours as well. So this will be 36 over 60. So let's calculate this. 25 divided by 82 plus 36 divided by 60. So 0.905 hours. 0.905 hours is the total time taken for the journey. So total distance is 45 kilometers. Total time is 0.905. So 45 divided by 0.905. So this is 49.7 kilometers per hour. 49.7 kilometers per hour. Part B is Anna's journey home is 47 kilometers, correct to the nearest distance, nearest kilometer. One day, her journey home takes 65 minutes, correct to the nearest 5 minutes. Calculate the upper bound for her average speed. So to calculate the average speed, so average speed is distance divided by time, right? So now we have to find the upper bound. So what is the maximum possible value? Upper bound means what is the maximum possible value of this average speed? And average speed is distance over time. So how can I maximize this value, distance over time? That means I need to increase the value in the numerator and decrease the value in the denominator to maximize the value of this fraction, right? So if the numerator gets bigger, the value gets bigger. And if the denominator value gets smaller, that means you're dividing by a smaller number, then the overall fraction value will increase as well. So that means, so let me write this upper bound of average speed, upper bound of average speed will be, so to increase the distance, I will take the upper bound of distance, upper bound of distance divided by the lower bound of the time, because I'm trying to decrease the value in the denominator. Lower bound of time. So what is the upper bound of distance? It's the distance value plus the error. So error is, so it's nearest to the nearest kilometer. So error in distance will be nearest kilometer. So 1 divided by 2, 0.5. So upper bound of distance is 47 plus 0.5 divided by error in time. First, we need to know the error in time before calculating this lower bound of time. So error in time is, so the time is correct to the uh, nearest 5 minutes. So error in time will be 5 divided by 2, which is 2.5. So the lower bound of time is 65 minus 2.5. So remember, this is in minutes. So average speed is in kilometers per hour. You have kilometers in the numerator, which is fine, but this is in minutes. So to convert this time into hours, I will divide this by 60. So now I will get 47.5 in the numerator, and let's calculate what do I get in the denominator. 65 minus 2.5 and then divided by 60. So I get 1.042. So 1.042 hours. So now the lower bound of time is 1.042 hours. The upper bound of distance is 47.5. Then we can calculate the average speed, which is 47.5 divided by 1.042. So up till three significant figures, this will be 45.6. Since there is an 8, I'll round this up. 45.6 kilometers per hour. Part C is the probability that Anna arrives at work on time or early on any given day is 5 by 8. Calculate the probability that she is late on both Monday and Tuesday. Give your answer as a fraction. So you have probability on time or late. Oh, sorry, on time or early or early. This is given as 5 over 8. So what is the probability of that Anna arrives late will be 1 minus this, because that is the only remaining possibility. You have on time, early or late. So your combined probability of on time or early is 5 by 8. So probability of being late is 1 minus 5 by 8. So this will give you 3 over 8. Now you need to calculate the probability that she is late on both Monday and Tuesday. So which is basically probability of late and late. So late on Monday on first day and late on second day, which is Tuesday. So this will be and, so I will multiply that 2. So I'll get 3 by 8 multiplied by 3 by 8, which is 9 over 64. Question 5 is AC and BD are the diameters. So these two lines are the diameters of circle with center O. AC is 12 centimeters and AOB is 130 degrees. Calculate the area of triangle AOB. So AC is 12. So this length is 12, which is the diameter. And this is the triangle for which we need to calculate the area, right? So this length is 12. So that means this length here, which is the radius of this circle, will be half. So AO is 6 centimeters. So to calculate the area of triangle AOB will be 1 by 2. So if this is 6, the radius, AO is the radius, that means BO is also the radius. So this length here is 6 as well. So I can use the formula 1 by 2 into AO into OB into the sine of angle between these two sides. So 1 by 2 into 6 into sine of 130. So sine 130 multiplied by 6 and then divide by 2. So this is 13.8. Calculate the area of sector AOD. So sector AOD is this one. So we need to calculate this area inside this red region. So if this angle is 130 and BD is a diameter, which means it's a straight line, that means this angle for this sector is 50 degrees. And we know that the radius is 6. So using the formula for the area of sector, so first angle AOD will be 180 minus 130, which is 50. 180 minus 130, 50 degrees. So area of sector AOD will be 50 divided by 360 into pi r square. Sorry, r is 6 square. So 50 divided by 360 into pi into 6 into 6. So this is 15.7. The next part is calculate the percentage of the area of the circle that is shaded. So to calculate the percentage of the area of the circle that is shaded, first we need to calculate the area that is shaded, then the total area of the circle, and then your percentage will be shaded area divided by the total area of the circle and then multiplied by 100. So we have already calculated the area of this triangle AOB. So the triangle DOC will be exactly the same, because this length is also 6, this length is also 6, which are the radius. This angle is also 130 because these are vertically opposite angles. So the area of this triangle and this triangle are the same. So, and then the area of this segment AD, which is this shaded area, is the same as this shaded area BC, because these angles are same as well. And then these lengths are equal. These are also radius. So we know this area that we calculated in the first part. So this we can multiply by 2 to get these two shaded areas. The only area that we need to find is this segment AD. So the area of this segment AD will be the area of the sector AOD, which is 15.7 that we calculated, minus the area of this uh, triangle. So this triangle here, AOD. So this angle is 50, this length is 6, this length is 6. So to calculate this area, this blue shaded area of segment AD, I will subtract the area of this triangle from the area of this sector AOD. So let's first calculate that area of segment AD will be area of sector AOD minus area of triangle AOD. So area of sector AOD is 15.7 minus area of the triangle AOD will be 1 by 2 into 6 into 6 into sine of 50 degrees. So this will be 1 by 2 into 6 into 6 into sine of 50. So let's calculate this. 1 divided by 2 into 6 into 6 into sine of 50. So this is 13.78 and then 15.7 minus the answer. So this is 1.91. So this is 1.91 centimeter square. So now let's calculate the area of shaded region. So this will be 2 times the area of this triangle AOB. So 2 times 13.8. So 2 into 13.8 plus 2 into this area of this segment AD, because the area of this segment BC is also the same. So I'll multiply this by 2 as well. So 2 into 1.91. So 2 into 13.8 plus 2 into 1.91. So the total shaded area is 31.42 centimeter square. Now area of the full circle. Area of circle will be pi r square, which is pi into r is 6 square. So this will be 36 into pi. This is 113.09. So let me write this down as 113.1. So percentage of the area of the circle that is shaded. So percentage of circle that is shaded will be area of the shaded region, which is 31.42 divided by total area of the circle, which is 113.1, then multiplied by 100. So this will be 31.42 divided by 113.1 into 100. So this will be 27.8 up till 3 significant figures. So this will be 27.8%. So 27.8% of the area of the circle is shaded. So the next question is, Zara fences off a piece of land next to a wall to make a vegetable garden. So this is the wall and she fences off this region, and inside this region you have the vegetable garden. The garden is a rectangle with the wall as one of the sides of the rectangle. So this side of the rectangle is the wall. The area is 18 square meters and the width is X. The total length of fencing required for the garden is y meters. Show that y equals to 2x plus 18 over x. So the total fencing required will be this width here, which will be also be x, this length here, plus this width, which is x as well. And on this side you have the wall, so you don't need any fencing on this side. So let's call this side L. So L will be, so if you have L as this length and X as this length, so the area of garden is L times X, and you're given that the area is 18 square meters, so this is 18 equals to L multiplied by X, and this gives you L equals to 18 over X. So total length of fence will be total length of fence will be X plus L plus X. So X plus L plus X. So this will be 2x plus L, where L is 18 over x meters. So you have shown that the total length of fencing required for the garden, which is y. So you have y here as the total length of the fence required for the garden equals to 2x plus 18 over x meters. Part B1 is complete the table for y equals to 2x plus 18 over x. So these are the missing values. So let's substitute x equals to 1 first of all. So this is 2 into 1 plus 18 over 1. So this will be 2 plus 18, which is 20. So this value here is 20. Then substitute x equals to 2. So this will be 2 into 2 plus 18 over 2. This is 4 plus 9, which is 13. And then the final value is for x equals to 9. So 2 into 9 plus 18 over 9. So this will be 18 plus 2, which is again 20. Part 2 is on the grid. Draw the graph of this equation for x between 1 and 9. So you have the table here. Let's plot the points from this table into the graph. So first value is 120, then 213. So 1 and 20 will be this value here. Then you have 2 and 13. So this is 15. So so there are 5. The value changes by 5, and there are 10 blocks. So that means each small block represents a value of 0.5. So 2 small blocks will be 1. So this is 15, this is 14, and then 2 blocks more, this will be 13. So this is 2 and 13, 3, 12, 4 and 12.5. So 3 and 12. So 3, then 11, 12. 4 and 12.5 will be this value here. Then you have 5 and 13.6. So 5 is here, 15, 14, 13, and 13.5 and 13.6 will be just above this 13.5 value here. So this is 5 and 13.6. Then you have 6 and 15, 7 and 16.6. 6 and 15, and then 7 and 16.6. 7, so this is 15 and 16, 16.5, 16.6 will be this value here. 8 and 18.3. 8 This is 20, 19, 18. So 18.5 is here, so just below 18.5 here, 18.3. And then 9 and 20. 9 and 20 will be this value here. So now we can draw the curve for this. Let me try again. So this will be your curve for this graph between for x values between 1 and 9. Part C is use your graph to find two possible widths of the garden if 14 meters of fencing is used. So on the y-axis, you have value of y, which is the total length of the fencing used. So we are looking for value of 14, which is this one. So this is 14. So on x-axis, you have the value of x, which is the width of the garden. So if you use 14 meters of fencing, the two possible values of the width is first is this one, and then the second point where this line intersects the graph is this. So first value will be this here. So let's bring this down. So this value is 1, 1.2, 1.4, 1.6, 1.8. And the other value is this one in the middle here. So this will be 5, 5.2, 5.3. So it's between 5.2 and 5.4. So the two values for which the garden fencing length is 14 meters, the two possible width values are 1.8 meters or 5.3 meters. Part D is the fencing costs $20 per meter. Find the minimum amount it will cost Zara to build the fence. So the minimum amount will be when the minimum length of fencing is used. So on y-axis, you have the length of the fencing. So minimum length is here, which is the value that we saw in the table as well. So 12 is the minimum value. So you started with 20, it kept decreasing up till 12. And after 12, it started to go back up. So y value is the total length of fencing. So if she wants to spend the minimum amount, she will need the minimum total length of the fencing. So minimum total length is this value here, which is 12. So if y, which is the length of fencing, minimum length of fencing is 12 meters. So minimum amount will be $20 is 1 meter. So 12 meters will be 20 into 12, which is $240. Part 2 is Zara wants to spend no more than $350 on the fence. Find the greatest possible width of garden Zara can make. So you have dollars and meters. So you get for $20 you can get a total. So this is total length of fence in meters. Total length of fence. So for $20 you get 1 meters. For $350 you will get X meters. So let's calculate the value. Not let me call this W because we already have a variable X. So for $350 you will get, so I'll cross multiply here. So this will be 20W equals to 350, and here the W value will be 350 divided by 20. So 17.5 meters is the uh, total length of the fencing she can buy for $350. So if you go back to the graph and look at the value for 17.5, so 15, 16, 17, and this is 17.5, right? So this is 17.5. So we want to find the greatest possible width. So when the total length of the fence is 17.5 meters, you have two possible values of the width. One is this one, but this is smaller compared to the other value, which is this one. So let me just change the color. So this is the greatest value of the width of the fence. This is also one possible value if I go down like this, but this is smaller than this width. So we are looking for the larger value of the width, given that total length of the fence is 17.5 meters. So this will be 7, 7.2, 7.4, 7.5. So this is around 7.5 meters, the greatest possible width of the garden if she wants to spend a maximum of $350 on the fence. Question 7 is triangle A is drawn on the grid. Transformation P is represented by this matrix. P maps triangle A onto triangle B. Draw and label triangle B. So that means if we multiply this matrix, transformation matrix P, with the coordinates of this triangle A, we should get the coordinates of triangle B. So PA will be, P is minus 2, 0, 0, minus 2. And the coordinates of the three vertices of triangle A, so this is 2, 1, 2, 1, this is 3, 1, 3, 1, and this is 2, 3. So this is a 2 by 2 matrix, this is a 2 by 3 matrix, so this cancels out, so I will get a 2 by 3 matrix. So let's multiply the rows with the columns. So first row multiplied by first column, I will get 2 minus 2 times 2 is minus 4 plus 0, which will be minus 4. This will be minus 6. Minus 2, 0 multiplied by 2, 3 will give me minus 4. And then this is 0 multiplied by 2 plus minus 2 multiplied by 1. So this will give me minus 2. This will give me minus 2 as well. And 0 multiplied by 2 is 0. Minus 2 multiplied by 3 will be minus 6. So the coordinates of triangle B will be, the one vertex is minus 4, minus 2, minus 6, minus 2, second vertex, and third vertex is minus 4, minus 6. So let's plot these points. Minus 4, minus 2 is this one. Then minus 6, minus 2. Minus 6, minus 2 is this. And minus 4, minus 6. Minus 4 and minus 6. So you can use the ruler to make sure the lines are straight. So this is your triangle B. Describe fully the single transformation P. So you're given this matrix P. So if we look at triangle A, which is mapped onto triangle B through this transformation P, this is an enlargement because the size of the triangle has increased. So to find the center of enlargement, I can connect corresponding points of the original triangle with the image. So this vertex in B is this vertex in A. So let's join these 2 points. And then this vertex in A is mapped onto this vertex in B. So let's join these. So they all, the lines connecting the corresponding points, they all intersect at origin. So that means the center of enlargement is 0, 0. And what is the scale factor? Scale factor is 2, because you can see this length was 1 here, the length has doubled. This length is 2, this length is 4. So the scale factor in fact is -2, because the image is on the opposite side of the center of enlargement. So the original object is here, image is on the opposite side. If this triangle B was on the same side somewhere here, on the same side of this center of enlargement as the original image, original object, then the scale factor is positive. But in this case, the scale factor is negative, and -2 is the correct value. So let me just erase these lines. So P is enlargement with center 0, 0 and scale factor is -2. Write down the ratio of area of triangle A, ratio area of triangle B. So you can see the corresponding sides, the ratio of their corresponding side is 1:2. If this side was length 1, this side is length 2. So the ratio of areas will be simply the square. So area of triangle A over area of triangle B will be simply the ratio of their sides, 1:2, and then squared. So this will be 1/4, which is 1:4. Transformation Q is represented by matrix this. Q maps triangle B onto triangle C. Draw and label triangle C. So similarly, again, we will apply this transformation onto the coordinates of triangle B, which will be mapped onto triangle C. So this is 1, 0, 0, -1. And let's look at the coordinates of triangle B. -4, -2, -6, -2. So -4, -2, -6, -2. And the last one is -4 and -6. So this will be, this row multiplied by this column will give me -4, 1 multiplied by -6, and then 0 multiplied by -2. So this will give me, add them together, -6. Similarly, this will be -4. 0 multiplied by -4 is 0, plus -1 times -2 will be +2. 0 times -6 is 0, plus -1 times -2 will be again +2. And then this will be +6. -1 times -6 plus 0 times -4. So these are the coordinates: -4, 2, -6, 2, and -4 and 6. So let's plot these. -4 and 2 is this. -6 and 2 is this. And the third one was -4 and 6. So -4 and 6 is this. So if you join these two with a straight line, you will get your triangle C, which is mapped. So triangle B is mapped onto triangle C. Part C is the transformation Y is represented by the matrix 1, 0, 0, 3. Y maps triangle A onto triangle D. So Y times A, you will get triangle D. Find the matrix that represents the transformation that maps triangle D onto triangle A. So to get A on this side, I will multiply it by Y inverse times Y into A, and then I will multiply Y inverse on the left side on here as well on the other side of the equation. So Y inverse by A will be simply identity matrix, which will leave A here, and Y inverse D. So that means Y inverse, when applied to D, maps this triangle D onto triangle A. So Y is given. So to find the inverse, first you will need determinant of Y, which will be 1 times 3 minus 0 times 0, which is 3. So y inverse will be 1 over determinant of y multiplied by the adjugate of y. So adjugate of y. So 1 over determinant will be 1 over 3 multiplied by adjugate is simply you swap the positions of these two. So 3 and 1 will swap positions and you change the sign of the other two. So zeros will remain zeros after changing signs as well. And then if I take this 1 by 3 inside, I get 1, 0, 0, 1 over 3. So this is the in matrix y inverse. And if you multiply y inverse with D, it will map D onto triangle A. So your answer here will be 1, 0, 0, 1 over 3. So question number 8 is the line 2y equals to x plus 4 is drawn on the grid here. On the grid, draw the line x plus y plus 2 equals to 0. So let's make y the subject here. So this will be y equals to minus x minus 2. So let's quickly draw a table. So let's take a couple of values of x. Let's take 0 as one value. And then let's take one here. Let's say minus 4 as the other value. And then for 0, when x is 0, y will be minus 2. And when x is minus 4, this will become plus 4. Plus 4 minus 2 will be 2. So 0 and minus 2 is this point here. And then minus 4 and 2 is this point here. So if we connect these 2 points, we will get the line for this equation. So let's draw a straight line through these 2 points. So this will be your line for the equation x plus y plus 2 equals to 0. The region R is represented by these three inequalities. 2y is greater than equal to x plus 4, x plus y plus 2 is greater than equal to 0, and y is less than equal to 2. So first you make sure that the coefficient of y is positive. So we already have these as positive. So we can simply, whenever we have a greater than equal to sign, we will shade the region above the line or towards the like up above that line. And when we have less than equal to sign, we shade the region below the line. But that is only true when you have positive coefficients of y. So if you don't have positive coefficients here, you have to first make sure you have switched to positive coefficients of y before shading the region. So anyways, we already have the equation for these two lines. The third line is y is less than equal to 2. So for this, we will need to draw the line y equals to 2, which will be this horizontal line. So let's draw that as well. So this is your equation. Oh, sorry, the line for y equals to 2. So now you have to shade the region above the line 2y equals to x plus 4. So this is the line that is already given. So above this line, also above the line x plus y plus 2 greater than equal to 0. So this is the equation x plus y plus 2 equals to 0. So this is the line for this equation. So above this line means this way. And then y is less than equal to 2. That means below this green line. So you will shade this region, which is the region R. And we can label this as R. Part B is the line L is perpendicular to the line 2y equals to x plus 4. Line L also passes through this point 1, 8. Show that the equation of line L is y equals to 10 minus 2x. So line L is perpendicular to this line. So let's first find the gradient of this line, which is, so 2y equals to x plus 4. If I divide by 2 on both sides, I get y equals to x over 2 plus 4 divided by 2 will be 2. So gradient of this line is 1 over 2. So that means, so let's call this line, let's call this M. So gradient of line M multiplied by gradient of line L should equal -1 because they are perpendicular to each other. So gradient of line M is 1 over 2, and gradient of line L is unknown. Gradient of L equals to -1. So from this we can find gradient of L will be, if I take this 1 over 2 to the other side, I'll multiply it by 2, so I will get -2. So now you know the gradient. So equation of line L will be y equals to mx plus c. So which is y equals to gradient is -2 minus 2x plus c. Now we know the line passes through these 2 points, so we can substitute x and y values here to find the value of c. So let's substitute 1 and 8 here. So y equals to minus 2x plus c, and y value is 8. Minus 2 times x value is 1 plus c. So this will become -2, and then c will become 10. If I take this -2 to the other side, 8 plus 2 becomes 10. So final equation of line L will be y equals to minus 2x plus 10, or y equals to 10 minus 2x in this form. So you have shown that the equation of line L is y equals to 10 minus 2x. Part C is use an algebraic method to find the coordinates of the point of intersection of the lines this 2y equals to x plus 4 and y equals to 23 minus 2x. So the point of intersection can be found by solving these equations simultaneously. So let's call this equation 1 and let's call this equation 2. So we can use the substitution method. So substitute y equals to 23 minus 2x from equation number 2 in 1, in equation 1. So if I substitute y, 2y will become 2 into 23 minus 2x equals to x plus 4. So if I open this bracket, I will get 46 minus 4x equals to x plus 4. And then I can take this 4x to this side and bring this 4 to the left. So I will get 46 minus 4 equals to x plus 4x. This will become 42 equals to 5x. And x will be 42 divided by 5, which is, so 42 divided by 5 is 8.4. So the x value is 8.4 for the, so this is the x coordinate of the intersection of these two. So let's find the y coordinate as well. So you can use this equation using equation 2, y equals to 23 minus 2x, and x is 8.4 now. So 8.4 into 2, 16.8, and then 23 minus 16.8 is 6.2. So the y coordinate is 6.2 here. Question 9 is the diagram shows a pyramid with a rectangular horizontal base. Vertex F of the pyramid is vertically above the center. So this is the center of the base, this point E. This length AB is 6.2 centimeters and BC is 4.3 centimeters. The length of each sloping edge of the pyramid is 9.5. So each of these sloping edges are 9.5 centimeters long. Show that the height EF, so this height EF of the pyramid is 8.72 centimeters, correct to 3 significant figures. So if you look at this triangle FEC, it is a right angle triangle. I know the hypotenuse length is 9.5, which is the sloping side. I can find this length EC. If I know this length EC, then I can use the Pythagoras theorem to find the vertical height, which I need to show is 8.72. So how do I calculate this length EC? If you look at this triangle ABC, which is like this. So this is in 3D. This is a rectangular base, right? ABCD is a rectangle. So that means this angle is a right angle triangle, and then this is A, B, and C. So this is 6.2, this is 4.3. So I can easily find AC using the Pythagoras theorem. AC square will be equal to AB square plus BC square. And once I have AC, my length EC will be half because this is the center point. E is center of the base. So AC square will be 6.2 square plus 4.3 square, and then this gives us AC as square root of this. Let's find this 6.2 square. Sorry, 6.2 square plus 4.3 square, and then square root of this. So this is 7.55 centimeters. So EC is 1 over 2 times AC, which is 1 by 2 into 7.55. So 7.55 divided by 2, 3.78. So this is 3.78 centimeter. Now I know that this is 3.78, this length EC. Now if I use this triangle FEC, I can write this as EF, in fact FC. FC is the hypotenuse. So FC square hypotenuse equals to the square of the other sum of the squares of the other two sides. So we have EF square plus this length EC square. Now FC is 9.5. EF is the height unknown that we need to find. So this will be EF square plus EC is 3.78. So this will be 3.78 square. So EF square is 9.5 square minus 3.78 square, and then this can give us EF. So let's calculate this. 9.5 square minus 3.78 square, and then square root of this is 8.72. So you have to show correct to three significant figures. So this one will be rounded up to 2 because the next value is 5. So this will give us EF as 8.72 centimeters. So I've shown this. Part B is calculate the volume of the pyramid. So volume of the pyramid is given as 1 by 3 into base area into height. So 1 by 3 into base area into height. So which will be 1 by 3 into base area. Base is a rectangle with length 6.2, width 4.3. So the area of the base will be 6.2 into 4.3 into the height is EF, which is 8.72 centimeters. 8.72. So the area will be 6.2 into 4.3 into 8.72, and then divide by 3. So 77.5 centimeters square. 77.5 centimeters square. Part C is calculate angle AFB. So AFB is this angle here, and this side is also the sloping edge. So this side is 9.5. AF FB is also the sloping edge, which is also 9.5, and this AB length is 6.2. So if you look at this triangle AFB, let me draw this. So if you look at this triangle AFB, so this is AFB. These are the two sloping edges which are 9.5 each, and then AB is 6.2. 9.5, 9.5, and 6.2. And you have to calculate this angle. So we know the three sides, so we can use the cosine rule here. So cos of angle AFB will be the sum of the, so let me write down first the sides. So AF square plus F BF square minus the opposite side of the angle, which is AB square, divided by 2 times AF times BF. So let's substitute the values. So this will be 9.5 square plus 9.5 square minus 6.2 square divided by 2 into 9.5 into 9.5. So let's calculate this. 9.5 square plus 9.5 square minus 6.2 square, and then divided by 2 into 9.5 to 9.5 into 9.5. So this is 0.787. So cos of angle AFB is 0.787. So AFB will be the cos inverse. So let's take cos inverse of answer. So this is 38.09. So up till 1 decimal place, it will be 38.1. So angle AFB is 38.1 degrees. Part D is calculate the angle of elevation of F from the midpoint of AB. So angle of elevation of F from the midpoint of AB. So let's call this the midpoint M. And so if I connect this M to this point E like this, and so the angle of elevation, so let's connect M to this point F as well. In fact, let me draw a solid line here. So this is the angle of elevation of F, of this point F from this midpoint M. Remember, this is in 3D. This pyramid is a 3D shape. So let me draw this triangle MEF from the side view. So if I'm looking from this side like this, the triangle will look something like this, right? So you have point M here, which is this point. E is the center here, and F is the top. So you're looking to find this angle. So this is E here. So this is the angle that you need to find, which is the angle of elevation of F from this point M. And you know that length, this length of the triangle EF is how much, which is the height of this pyramid is 8.72. So this is 8.72. And this length ME will be half of this full length BC. So this length ME is 4.3 divided by 2. So now from this triangle, I can use tan of this angle. So let's call this theta. So tan of theta will be 8.72 divided by 4.3 over 2. So ME. So let me quickly draw this here as well. So this is 4.3 over 2. This is, the height was 8.72. 8.72. This was the midpoint. This is point E, sorry. And this is F. And this is the angle that we want to find. So tan of theta will be 8.72 divided by 4.3 divided by 2 will be 2.15. So this is 2.15. So theta, which is the angle of elevation of F from M, will be tan inverse of this. So 8.72 divided by 2.15, and then tan inverse of this will be 76.1 up till 1 decimal place. So this is your angle of elevation. So question number 10 is the diagram shows two circles that touch at this point C. ABC are points on the small circle and center is X. CDE are points on the large circle with center Y. AXCYE, this is a straight line, and BCD is also a straight line, and this angle here is X. Prove that triangle BCX is similar to triangle DCY. Give a reason for each statement. So BCX is this triangle, and DCY is this triangle. So we can first see that angle BCX, this angle and this angle are equal. So angle BCX equals to angle DCY because they are vertically opposite angles. Vertically opposite angles. And then since X is the center of this small circle, that means these two are radius, so they will be equal in length. And similarly, this length YC and this length YD are both radius of this large circle. So these two lengths will be equal as well. So from this, we can say that angle XBC is equal to angle BCX, and angle DCY is equal to angle CDY because uh, because triangle XBC and triangle CDY CDY are isosceles. So then it means this angle is equal to this angle, and this angle is equal to this angle, and since these two are equal, that means angle XBC, or you can say so XBC, this angle XBC will equal angle CDY. So we have shown that two angles in each of the triangles are equal, so that means the third angle will automatically be equal. So this angle here will be equal to this angle. So that means BXY will equal, BXC will equal angle BXC will equal DYC, which is the third angle in the triangle. So that means all three angles are equal. That means triangle BCX and triangle DCY are similar. Part B is find in terms of X angle DCY. So let me erase this. So you have to find the angle DCY, which is this angle here. So since dy is the radius, ye is also the radius. So if this angle is x, this angle is x degrees as well. And this angle CDE will be 90 degrees because this is an angle in semicircle or angle subtended by this diameter on the circumference of the circle. So if you look at this triangle CDE, we know that the sum of angle DCY plus 90 plus this x should equal 180 degrees. So let me write this down here. So angle DCY plus 90 degrees plus x will equal 180. So if I take these to the other side, this will give me DCY equals to 180 minus 90 will be 90, and this x will become negative x. So your angle DCY is 90 minus x. The next angle that we have to find is angle BXA. So BXA is this angle here that we need to calculate. So we have already found that DCY is 90 minus x. So that means this angle XCB will also be 90 minus x because they are vertically opposite angles. And both angles BXA and BCX are subtended by this same arc. So this arc makes this angle at the center, whereas it makes this angle at the circumference. We know that the angle at center is twice the angle at circumference. So BXA will be equal to 2 times the angle BCX. BCX, which is BCX is the same as DCY because they are vertically opposite angles. So this will be 2 into 90 minus x, which is 180 minus 2x. So BX is 180 minus 2x. Part C is given that BC is 3.5, CX is 3.2, and CD is 5.6. Find the length AE. So let's erase everything and mark these lengths. So BC is 3.5 and CX is 3.2. So BC is 3.5, CX is 3.2, and CD is 5.6. CD, this length is 5.6. And we have to calculate the length AE. So AE is basically this full length here. So if this is 3.2, this is the radius. So this is 3.2 as well. And if we find this value CY, YE will be the same as well because both CY and YE are radius for this large circle. So since we proved that triangle BCX is similar to triangle DCY, we can use the property of similar figures, similar triangles, where the ratio of their corresponding sides will be equal. So that means this side BC and this side DC. So BC over DC will equal this side, which is CX, over this side, which is CY. So BC over DC over DC will equal CX over CY. CX over CY. And the unknown value here is this length CY. So let's substitute the value. BC is 3.5, DC or CD is 5.6, CX is 3.2, and CY is unknown. So if I take this CY, if I cross multiply, I'll get CY equals to 3.2 into 5.6 divided by 3.5. So 3.2 multiplied by 5.6 and then divided by 3.5. So this is 5.12. CY is 5.12 centimeters. So now length AE is how much? Length AE is AC plus CE. So this is AC plus CE, and this length AC is 2 times this length CX. So this will be 2 times this length CX, which is 3.2. 2 into 3.2 plus CE, this length here, is 2 times the length CY. So 2 times the length CY is 5.12. So let's calculate this. 2 into 3.2 plus 2 into 5.12. So this is 16.64 centimeters. So your length AE is 16.64 centimeters. So this is the end of paper 2, variant 2 for October, November 2018.